Welcome to Basic Electronics lecture series. I, Professor Hitesh Dolakia, is going to explain you PN junction diode under reverse bias condition in this video. In my previous video, I have already explained you PN junction diode under forward bias condition. So let us have PN junction structure first. P-type layer is having majority carrier as holes. So I am showing majority carrier as holes here. An N-type layer is having minority carriers as holes. So I am showing few holes here. N-type layer is having electrons as a majority carrier. So I am showing electrons here as a majority carrier. And P-type layer is having minority carriers as electrons. So I am showing few electrons here. Now see, when we diffuse P-type and N-type layer together, holes of P-type material is accepting electrons, so that will be generating negative ion at the side of P-type layer, and electrons of N-type layer is donating electrons, so that is generating positive ions at the side of N-type layer. So let me show it over here. So you can observe at the side of P-type layer there is negative ions, and at the side of N-type layer there is positive ion, and this is referred as depletion region. This region is referred as depletion region. Under no bias condition, width of depletion region is W, and you will be observing potential barrier, that is V0. And this potential barrier that is happening because of negative and positive ions. Now see, in depletion region there will be no charge carriers, right? And depletion region does not allow flow of current. Now our question is PN junction diode under reverse bias condition. So when you keep PN junction diode under reverse bias condition, you will have to connect P-type material with negative terminal of battery and N-type material with positive terminal of battery. So you can observe this battery is having positive terminal connected with N-type layer and negative terminal with P-type layer. So that is how we have this PN junction in reverse bias condition. Now let us increase reverse bias voltage from 0. So what will happen? Now you see, if you increase this reverse bias voltage from 0, you see this P-type holes that is getting force in this direction, and this N-type electrons that is getting force in this direction because of this positive plate, and negative plate is forcing holes in this direction. So there will be increase in width of depletion region over here, right? So as you increase reverse bias voltage, there will be increase in potential barrier, as well as there will be increase in width of depletion region. So if I say I am having certain amount of voltage V which is there in the reverse bias, what will happen? If V is greater than 0, you will be observing change in depletion width. Let us say it is now W dash. So it will be always greater than 0 depletion width, right? So depletion width will increase. Now what will happen with current? So as depletion region that is getting broadened, you will be observing current will happen due to minority carriers only. So here, as if I want to talk about current, then current due to majority carrier, that is always 0, right? Here current will be there due to minority carrier only, right? And I can say minority carrier means it is reverse saturation current, right? So this current will happen, and that is purely based on temperature. That is purely based on temperature. So if you increase temperature, there will be generation of minority carriers. In P-type layer there will be generation of electrons, and in N-type layer there will be generation of holes. so those minority carriers will flow current in reverse bias, and that will be very small. You will be observing that is there in terms of micrometer and nanometer, while in forward bias there will be current due to majority carrier, right? So here in reverse bias condition, one can say current is very less, that is due to minority carrier only. And let us try to understand that in characteristics. So I am showing now reverse bias characteristics of PN junction diode. You will be observing characteristics of reverse bias is there in third quadrant. Why it is there in third quadrant? The reason is you will be observing here voltage is negative. You see now polarity is like minus plus with P and AND, so it is negative voltage, and here current is flowing due to minority carrier, right? So current is negative. So here voltage and current both are negative, so one can say characteristic is there in third quadrant. Now what will happen when you increase reverse bias voltage? So obviously in reverse bias current is flowing due to minority carrier only, right? So you will be observing this much amount of current that flows due to minority carrier, or one can say this current is reverse saturation current. And once there is a breakdown, there will be high amount of current flow. But because of breakdown, there is a possibility that there can be permanent defect in PN junction. So once there is a breakdown, there will be high current flow, right? And this voltage, that is referred as reverse breakdown voltage, right? And in normal PN junction diode, there should not be reverse breakdown. If it is happening, in that case there is a possibility that diode may have permanent damage. So these are the basic things that we should keep in our mind. In next few videos, I'll explain you ratings of diode as well as what are the basic conventions that we need to take when we use diode in circuit. I hope you have understood this video. Thank you so much for watching this video. Please do give your valuable suggestions.